Hello everyone, this is Practical Organic Chemistry and this is the third lab lecture for this semester, and in this lab lecture we'll be looking at synthesis of stilbene. For more information regarding synthesis of stilbene, you can refer to your textbook section 28 from page 336 to 370. So stilbene is an organic compound naturally found in many natural resources. It's also important organic compound as it has medicinal value, but also it has found application in photonics and optoelectronics. So this lab lecture is all about how we can synthesize stilbene chemically. We have both cis and trans stilbene, and the name stilbene, the IUPAC name of stilbene, including its stereochemistry, can be written as bracket E 1,2 diphenyl ethene, or you can also write bracket E 1,2 diphenyl ethylene. So what's interesting in this compound is that because this compound makes a rearrangement in the orientation of one of its bonds in space, it results in two compounds with the same molecular formula and of course molecular weight, but with different physical property. For instance, the trans stilbene is a white solid that white solid at room temperature, whereas the cis stilbene is colorless, and the melting point of the solid is in the range of 122 to 125 degrees Celsius, whereas the liquid cis stilbene melts only between 5 to 6 degrees Celsius, and of course it boils at 317 degrees Celsius, and both of them are water insoluble. So synthesis of stilbene can be started from benzaldehyde and a very important electrophile, which also later acts as a nucleophile, called benzyl triphenyl phosphonium chloride. So the overview of the reaction is we have benzaldehyde and we have that reagent, and we make this reaction in an alkaline solution using an organic solvent, methylene dichloride, to synthesize racemates of stilbene, both cis and trans of stilbene. And of course the reaction has byproducts such as triphenyl phosphine oxide, sodium chloride, and water. So a synthesis starts from synthesizing the important reagent for this experiment, and we can synthesize that from triphenyl phosphine and benzyl chloride. So triphenyl phosphine acts as a nucleophile. Definitely this is an SN2 reaction where the phosphorus lone pair of electron displaces the chlorine from the benzyl chloride, and also the substrate, the benzyl chloride, can also be benzyl bromide in different textbooks, but it won't make any change in the product. You can simply substitute chlorine by bromine. So at the end of the reaction, we get the important reagent benzyl triphenyl phosphonium chloride. And so When this reagent is hydrolyzed in alkaline solutions, then what happens is the hydroxyl group from sodium abstracts a proton, uh, and the proton bond electron is delocalized to carbon phosphorus bonds to neutralize the electron deficiency on phosphorus and give us the final structure, which also called Witting reagent. And this is the first step in the synthesis of Stilbene. Along with this, the scientist who synthesized this one is also called Witting. That's so the reagent is named after the scientist himself, and he has won a Nobel Prize in chemistry in 1979 because of this work. So in the actual reaction, what happens is the Witting reagent rearranges its double bond, and the double bond, the pi bonds after opening becomes carbanion on the benzyl carbon, and they use it as a nucleophile to attack the carbonyl carbon on the aldehyde, which accounts to the second step. And then again, the formed intermediate rearranges by heating back the phosphorus cation with delocalized oxygen pi bonds, oxygen carbon pi bonds, and they give us a cyclic neutral intermediate called oxaphosphetane. And then this oxaphosphetane undergoes intermolecular rearrangement and gives the final product, the triphenyl phosphine oxide, which is a byproduct, and our major products, of course, the cis and trans stilbene. And in the experiment, we'll be performing all these steps in one by one. So the first step for the practical uh, uh, task is to have a dry clean separatory funnel, and with a right size stopper and a ring clamp, which will be using it to allow the separatory funnel to stand so that we will have layers. So to start, we add 3.9 grams of benzyl triphenyl phosphonium chloride into the separatory funnel, and then when we add, we may have some powders stick on the way in the separatory funnel, and we can wash them with 50 milliliter of dichloromethane. And then we add 1.1 to 1.2 milliliter of benzaldehyde, followed by our alkaline solution, 40 milliliter of 50% sodium hydroxide. And then we shake the funnel for about 35 minutes. You can also go to 40 minutes in this case, but try to not shake the separatory funnel the whole time at once. You must consciously vent the separatory funnel every few minutes, every 5 or even every 4 minutes, so that because the solvent we're using is an organic solvent, and it may lead us to an explosion, and we need to make sure that the separatory funnel is vented appropriately and at the right time. Then the next step is to add again 2 milliliters of methane, and then keep the shaking, and of course with frequent venting. And then we put the separatory funnel in the ring stand so that we allow layers to form, and we will have two layers forming, and we then drain the lower layer, which is the aqueous layer containing sodium hydroxide. And then we add 10 milliliters of tap water into the separatory funnel and again shake it gently. And even if it's water, you may need also to vent this if you are shaking it for a very long time. And then the final step before we collect before we dry our final sample is to just because once we remove the aqueous layer, the remaining organic layer in the top layer in the separatory funnel is the layer that contains our desired product, and we then collect that into a clean Erlenmeyer flask. And then to dry out our product, we add the dehydrating agent magnesium sulfate, about 2 spatulas. And then to separate the magnesium sulfate, we conduct a gravity filtration. So I hope we will have a slide to recall you about how to perform the gravity filtration. But once you do the gravity filtration, then the next task is to store your sample in your designated cabinet for the next experiment or for further experiments. So here again we need to repeat so that you emphasize the message. When you do the shaking, please the dichloromethane is an organic with a boiling point 41 degrees Celsius, which means it's volatile, and unless you shake it occasionally, you may end up blowing the funnel, and if the funnel blows, you will not also be safe. So please pay attention to do this. And also 50% sodium hydroxide is very concentrated, and because any solution of sodium hydroxide is corrosive, and when it is extremely when it is high concentrated, you can imagine how corrosive it can be. You can avoid this by wearing safety goggles, which are available in the lab. And of course, the TA will also instruct you to wear gloves before you even start the experiment. But I mean, let's come here. It's just your skin. It's just your body. So even if you're not told by the TA, you should remember to wear safety gloves and goggles. And in case if you have if any even a drop of this alkaline solution spill in your skin, the first aid is to wash with fast running water. And again, the dichloromethane is volatile and nobody needs to inhale it because it's a halogenated solvent, and it doesn't do good to our breathing system, and that's why the whole experiment is recommended to be performed in the fume hood. Just to recall you, to make a filter paper, you can take the filter paper, Wattmann filter paper available in the lab, fold it into half, fold it into quarter. You keep folding until you reach the minimum folding capacity for the filter paper. Even if it's not that difficult, but so many students do it wrong way, so it's good to just recall your know-how about how to make the fluted filter paper. And again, another important part of all experiments is how to handle waste after each of the experiments. We have used magnesium sulfate to dry out our sample, and the filtered magnesium sulfate along with the paper will be a solid waste. Okay, and we have also recovered the sodium hydroxide solution after at the bottom layer in the separatory funnel, and it will then be an aqueous waste. Again, any excess or filtrated dichloromethane are wastes, but because these are organic wastes, they should be stored in a separate container. Normally, we label containers for storing of organic compounds by halogenated waste. That's how it's labeled in most laboratories, as far as I know. And cleaning is again most important, and here we have used the separatory funnel, we have used Erlenmeyer flask, we have used beakers, and all of them must be washed and returned to their appropriate cabinet. Also, we were working on the hood, or you will be working on the hood, and it's good to again clean the area around you were working with the soap and water. And again, also if you use the balance to measure, and of course you will be using the balance to measure the sodium hydroxide before you make the 50% solution. You may also use to measure the magnesium sulfate, unless the TA makes it ready before the experiment. And all this equipment and glasswares you use it must be clean and returned to their respective cabinets. And the TA is responsible here to make sure that you do all this. That's all for this lecture, for this week's lecture. If you have any question or comment, you can leave it in the YouTube channel where I will be posting this lecture. You can also email me if you have any question with the quizzes in addition to this material.